Now that we've learned about the properties of right triangles and we've learned about the law of sine and cosine, let's look at applications that possibly involve all three of these things. And here's an example. Lisa is 800 meters from the base of a mountain. All right, so here's Lisa. We have an image here. We have Lisa on the bottom left and 800 meters. She's 800 meters from the base of a mountain. From where she stands, she measures the angle of elevation to the peak of the mountain to be 38 degrees. So that angle of elevation is 38 degrees. Lisa's looking at it horizontal, and then she looks up at the peak of the mountain. She then walks to the nearest part of the base of the mountain. Lisa measures a new angle of elevation, this time getting 49 degrees. All right, so she moves in 800 meters to the base of the mountain. She looks up and measures that new angle of elevation as 49 degrees. The question is, how far is Lisa from the peak of the mountain when she is standing at the base? And that is the piece that is listed with a question mark. All right, I'm going to let that be called X. Round your final answer to the nearest 100 meters. All right, so I'm going to let X equal the distance from Lisa to the peak of the mountain. And we are in meters. We are in meters. Okay, so what do we have going on here? We were given, we were given an angle of 38 degrees. We were given the side of 800. And we were also given an angle of 49 degrees. Now, 49 degrees is not in the same triangle as the 38 degrees and the 800 are. Wouldn't it be nice, let me just erase some of this. It would be real nice, and I think possible, if we could find out what this angle is so that we are looking at one little teeny weeny triangle that has an angle measure of 38, a side of 800, and an angle of, what is that angle measure? Well, that angle measure added to 49 degrees is half of a circle. So that angle measure at the base of the mountain is whatever 180 degrees minus 49 degrees is, and that is 131 degrees. So we now have an angle, a side, and an angle, and we know that means we can use the law of sines. Okay, and what we need with the law of sines is an anchor, right? So we have the 800 meters. The angle across from it is what we need to determine. Well, if we have 38 degrees and we have 131 degrees, then this little angle up at the top, what is that? That's 180 degrees minus the 38 that was given minus the 131 that we calculated. That ends up giving us an 11 degree angle. So it is pretty teeny, 11 degrees, but doesn't matter how teeny it is. It is across from the 800 meters, and we now have an anchor, don't we? So knowing I said I was going to let that question mark be X. If I want to find the measure of X, then I'm going to say X over the sine, what angle's across from X? Looks like 38 degrees. And that's going to be equal to my anchor. My anchor is 800 meters over the sine of 11 degrees. Okay, I'm going to multiply each side by the sine of 38 degrees. That gives me X being equal to whatever 800 times the sine of 38 degrees is, all over the sine of 11 degrees. And when I put that into my calculator, I got X is equal to, approximately 2805.446798. And they want me to round to the nearest 100 meter. Now, that's not hundredths, that's 100. And the 8 is in the 100 position. The 0 tells me not to round up, but actually to round down. So we're going to say this: Lisa is approximately 2,800 meters from the peak of the mountain. And that is, of course, when she is standing at the base. All right. Let's try another one. A billiard ball starts 86 centimeters from the corner pocket as shown. All right, let's just make sure we see that. So 86, here's the ball, and the corner pocket is right down here, and they are 86 centimeters apart. The ball rolls 120 centimeters in one direction. It hits the rail. Okay, so we hit the ball, goes 120 centimeters, it hits the rail, bounces off, goes 100 centimeters, and straight into the pocket. How convenient is that for us? It just formed a triangle. What is the angle between those two paths before and after the ball hits the rail? Round your final answer to the nearest degree. All right, so this question mark I'm going to call x, and I'm going to define x to be equal to the angle between the paths of the ball. The path of the ball, I'll say. And that is in degrees. Not in radians, it's in degrees. So that is my unit in this case. Now, what has been given to me? What has been given to me, we started with the 86, then the 120, and then the 100. So we have a side, side, side triangle, and that is the law of cosines. It's really helpful, I think, to identify what type of triangle that you have so that you know exactly what properties you should use. Okay, so I want to find angle x, and that's in degrees, and so I need to connect that with this side of 86. I'm going to say that 86 to the second power is equal to 120 to the second power plus 100 to the second power minus 2 times 120 times 100 times the cosine of whatever x happens to be, and that's in degrees. You can understand maybe when I said earlier committing the law of cosines to memory, you write this out enough times and it starts to feel like you just know it. You're not memorizing it, you just know it. At least that's my hope. All right, so now I'm going to start trying to solve for the cosine of x. And so what I have to do then is isolate that. So I'm going to take 86 squared, I'm going to subtract 120 squared, I'm going to subtract 100 squared, and that's going to equal negative 2 times 120 times 100 times the cosine of x. I will divide both sides by that negative 2 times 120 times 100, right? Those will all cancel out on the right, but then I have to do it on the left. And you'll notice that, yeah, I could probably multiply those out, and I could write just one number, but I can also just put this whole numerator into my calculator and divide it by this whole denominator to end up getting that the cosine of x is equal to, when I put that all in, I got 0.7085. Now that's not the answer for the angle, that's the cosine of the angle. So now I need to take the inverse of each side, and I'm writing it out. So cosine inverse 0.7085. Don't get lazy in how you write this. You want to make sure that your notation is good. And the inverse undoes the cosine, and I'm left with x being approximately 44.89, and that's in degrees. So the question was, what is the angle between the paths? And round your final answer to the nearest degree. So I'm going to say the angle between the paths, or the path of the ball to the nearest whole degree, is going to be 45 degrees. Let's try one more example. Sherman needs to determine the height of a tree before cutting it down to make sure that it won't fall on top of a nearby fence. The angle of elevation from one position on a flat path to the tree is 40 degrees. And then from a second position, 20 feet farther down the path, is 30 degrees. What is the height of the tree? Round your final answer to the nearest foot. All right, so we have a tree. Should I make that tree green? Here's my tree. And make that tree. I'm going to assume that tree is perpendicular to the ground. And let's see, what else do I know? Sherman is on the ground on a flat path. And angle of elevation is to the top of the tree is 40 degrees. So this angle right here is 40 degrees. And then from a second position, 20 feet farther, so this piece here and this piece here is 20 feet. And now the angle of elevation is 30 degrees. It's a little smaller, which is making sense with my picture. What is the height of the tree? I'm going to call the height of the tree h. And don't forget I said we're going to assume that that tree formed a right angle. So I'm going to say let h equal the height of the tree, in feet. Okay, now because the height of the tree is part of a right triangle, I might be able to use my SOHCAHTOA rules. I know the 40 degrees that's across from h. So I could say, let's see here, across or opposite, I could say that the sine of 40 degrees is equal to the side opposite over the hypotenuse. Well, the hypotenuse I'm going to call x, and I don't know x. So that's not getting me too far. However, I do have this other triangle that's inside. Let me just shade it. It's this little sliver of a triangle. And the reason why I'm thinking about using that is because I have this 20 feet on the end. I know 20 feet, I know 30 degrees. I think I could find this angle that's right here on the inside, because that angle, along with the 40 degrees, forms a straight line, which is half of a circle. So I could say that that angle is whatever 180 degrees minus 40 degrees is. That's 140 degrees. That tells me that the angle up at the top is whatever is left over to get me to 180 degrees. So I've got 180 degrees minus the 140 degrees I just found, minus the 30 degrees, and that's going to get me a 10-degree little angle on the inside. And that I like, because that 10-degree angle, along with my 20 feet, and the 10-degree angle, I've just got my anchor, don't I? So what I want to do is solve for x and then use that x value to then solve for h. So I'm going to say that x over the sine of 30 degrees is equal to the 20 feet over the sine of 10 degrees. And I'm going to multiply each side by the sine of 30 degrees to get that x is equal to 20 times the sine of 30 degrees all over the sine of 10 degrees. And when I put that into my calculator, I got that x is equal to 57.58770483. Now, that is not my final answer. That is simply the thing that I'm going to use to substitute into my SOHCAHTOA. So I'm going to say that this is equal to h, the sine of 40 degrees is equal to h over approximately 57.6. Now, of course, I'm not going to use the 57.6 in my calculation. I'm going to use the full number. Now, I will multiply each side by that 57.6 so that I can say that h is equal to whatever 57.6 times the sine of 40 degrees is. And when I put that into my calculator, I got that h is equal to approximately 37.02 feet. This one asked me to round to the nearest foot, so I'm going to say that the height of the tree is 37 feet. So this is an example of a problem where we really have to take all the things that we know, the right triangle rules, law of sine, law of cosine, and determine maybe we have to use one of them, maybe we have to use two of them, but we have options, don't we? And that's really the way you should think of these, not just in isolation, but how do I use all of these properties that I've been learning in order to solve problems?